Fresh images just dropped, and they're shaking astronomy to its core. On November 16th, observers captured the clearest photos ever of 3I/ATLAS, revealing something that shouldn't exist: jets of plasma shooting directly toward the sun. This defies everything we know. Solar wind pushes material away, not toward it. Yet here's our third ever interstellar visitor, racing at 130,000 miles per hour, brazenly breaking the rules. Astronomers are scrambling for answers. Natural venting, rotational quirk, or something far stranger. Let's dive right in. Let me be completely honest with you. When I first saw these images, my hands literally froze over the keyboard. Because what we're looking at shouldn't exist according to everything we understand about how comets work. 3I/ATLAS isn't just any comet. It's the third confirmed interstellar object in the entire history of modern astronomy. We've been pointing our most powerful telescopes at the sky for decades, scanning billions of stars, and we've only confirmed 3 visitors from beyond our solar system. This one is racing through our cosmic neighborhood at 130,000 miles per hour. At its closest approach to the sun on October 29th, it hit 42 miles per second, fast enough to cross the entire United States in about 90 seconds. But speed isn't what's keeping astronomers up at night. When observer Satu Morata captured those crisp images on November 16th from New Mexico, the astronomical community collectively held its breath. These were the clearest, most detailed photographs we've ever obtained of 3I/ATLAS. And they revealed something that made every physicist do a double take. The comet has multiple tails and jets, completely normal, except there's one jet shooting plasma directly toward the sun. Not away from it, toward it. If you've ever seen a comet photograph, you know the tail always points away from the sun. Always. This isn't some guideline, it's fundamental physics. The solar wind blasts off the sun at 900,000 miles per hour, pushing everything away. There's no negotiation. It's like trying to walk into a Category 5 hurricane. You don't get to choose your direction. Yet here's 3I/ATLAS, casually defying that rule. In the entire documented history of comet observations, we can count on one hand the number of objects that have exhibited this behavior. 1. Hand. So, when scientists see this, we don't just shrug and move on. We stop everything and ask, what are we missing? The most straightforward explanation involves rotational venting. Imagine the comet spinning while internal pressure from sublimating ice forces gas jets out at specific angles. If the rotation timing and vent positioning line up just right, you could theoretically get jets pointing sunward despite the solar wind. It's like a spinning lawn sprinkler where water shoots out at angles that seem to defy the pressure direction. But here's the uncomfortable truth. For this to work, you need incredibly specific conditions. The rotation rate has to be exact. The internal vents positioned perfectly. The pressure channels structured just right. It's technically possible, but it's like dropping a deck of cards and having them land in perfect sequential order. There's another possibility that honestly excites me more. What if 3I/ATLAS contains chemical compounds we've never encountered in solar system comets? This object didn't form here. It came from a completely different stellar environment, different temperatures, different radiation, different chemical processes brewing for millions of years. We're looking at alien chemistry in the most literal sense, and we don't have a reference manual. Let me take you back to July, because that's when this story really began. Hubble captured the first clear images of 3I/ATLAS when it was still far from the sun. Even then, something looked strange. The bright outer corona appeared to be tilting toward the sun instead of being pushed away by radiation pressure. Multiple observation sessions confirmed this wasn't an imaging error. The phenomenon was real, then mysteriously vanished as the comet entered the observation dead zone near perihelion. Conservative astronomers filed this under rare characteristic of interstellar comets and moved on. But think about that phrase for a second. We've confirmed exactly two other interstellar objects, Oumuamua and 2I/Borisov. That's our entire data set. Calling anything a characteristic based on three examples is like watching three people and declaring you understand all of humanity. After perihelion, things escalated. Multiple observatories captured the tail, morphing through different configurations, sometimes thread-like and narrow, then spreading into intricate plasma bands, sometimes fragmenting into multiple streams that later recombined. What caught everyone's attention was the rhythm. These changes weren't random, they were almost periodic, like a heartbeat. The Virtual Telescope project documented this between November 8th and 10th, frame by frame. The entire progression happened over days, not the weeks or months we'd expect. It was like the comet was responding to internal processes rather than external solar pressure. Now we need to talk about energy, because the numbers are staggering. In deep interstellar space, 3I/ATLAS received about 0.0000001 watts per square meter of solar radiation. For potentially millions of years, this object drifted through the void in deep cold. Then it approached our sun, and suddenly, cosmically speaking, it's being hit with more than 1,400 watts per square meter. That's an energy increase of 10 billion times. Imagine spending your existence in absolute darkness and freezing cold, then having 1,000,000 searchlights turned on while the temperature cranks to maximum, all in a few months. Post-perihelion images show plasma streams brighter and more dynamic than anything observed before. The dust production exploded. Gas jets intensified. The entire object woke up from millions of years of dormancy. This raises something genuinely fascinating. We've always thought of dormant comets as inert ice balls, dead rocks with frozen water. But what if that's too simple? Complex organic molecules form in interstellar ice. When you flood them with massive energy, could you trigger chemical reactions we haven't documented? Chemistry that looks almost purposeful but is actually exotic reactions following unfamiliar pathways. I'm not suggesting anything artificial, but our dirty snowball model might be crude compared to reality. Here's where things get interesting. The European Space Agency's ExoMars orbiter had perfect positioning to observe 3I/ATLAS from a different angle than Earth-based telescopes. Scientists expected detailed imagery that would answer burning questions. Instead, ESA released images that were underwhelming, blurry, lacking detail far below what the instruments could produce. I'm not suggesting conspiracy. Space missions are complex, and technical issues happen constantly. But when you don't get clear answers, people fill in the blanks themselves. Then, on October 3rd, the European Southern Observatory announced they'd refined the orbital calculations by a factor of 10. That's an unusually sharp precision jump. The good news? The refined orbit confirmed 3I/ATLAS is following a clean hyperbolic trajectory with zero deviation. The small accelerations are entirely consistent with standard cometary outgassing. If this object were under intelligent control, we'd see trajectory variations. We're not. Whatever strange phenomena we're observing, the comet is following ballistic physics perfectly. Right now, 3I/ATLAS is making its closest approach to Earth. December 19th marks its nearest point before continuing outbound. Amateur astronomers are capturing remarkable images, and what they're documenting confirms everything. Those jets remain active, that bizarre sunward plasma persists, the tail continues shape-shifting, and critically, it's all happening exactly where predictions said it would. But then we hit a communication disaster. Around the same time, another completely different comet called K1A-TLAS began breaking apart. Different object, different orbit. But the similar names created chaos. Social media exploded with reports that Atlas is fragmenting. Within 48 hours, millions believed they were watching an interstellar object disintegrate. None of it was true. 3I/ATLAS remains intact, simply fading as it moves away. Exactly what should happen. The confusion was purely about naming similarity and how information mutates online. On March 17th, 3I/ATLAS will make its closest approach to Jupiter. The gas giant's gravity will give it a final handshake before it heads back to interstellar space. This encounter lets astronomers finally nail down its mass, the one parameter we still don't know precisely. NASA's preparing high-altitude observations that should reveal the nucleus, size, and structure definitively. Here's what matters most. Strip away speculation and focus on what we know. We have an interstellar comet exhibiting rarely observed behaviors, jets pointing toward the sun, rapid structural changes, unusual activity, all from an object that formed around another star with chemistry we don't understand. The real mystery isn't whether this is artificial, it's not. The real mystery is what this teaches us about our assumptions. For decades, we've built comet models based exclusively on solar system objects. We've assumed ice behaves predictably, structures follow patterns. 3I/ATLAS is dismantling those assumptions. Interstellar comets don't play by our rules, because they didn't form here. Different stellar radiation creates different chemistry. Different thermal histories create different structures. When that alien composition hits our sun's energy, it responds in ways our models never predicted. What excites me most is that this is science working exactly as it should. We're not confirming what we thought we knew. We're discovering reality is stranger than our theories predicted. That's not failure. That's science succeeding at its core mission, following evidence wherever it leads. Here's what 3I/ATLAS is teaching us and why it matters. Those Sunward jets aren't breaking physics. They're revealing that interstellar chemistry operates in ways our solar system models never predicted. This is the third confirmed visitor from beyond our solar system, and it's already rewriting what we thought we knew about comets. Different stellar environments create different rules. The real story. We're witnessing science in action. Not confirming old theories, but discovering that reality is stranger and more diverse than we imagined. And this is just object number 3. How many more are passing through right now that we're missing? What will the next visitor teach us? NASA's releasing new high-altitude imagery within days. In March, Jupiter gives this comet its final gravitational push back into interstellar space. The story's far from over. If you want the next major 3I/ATLAS update before it hits mainstream news, do 3 things right now. Hit that like button. It tells YouTube to push this to more people who care about real space science. Drop a comment below. Do you think this is exotic chemistry or something even stranger? Your perspective matters. Subscribe to Galactic Breaking News and turn on notifications, because when NASA drops those new images or when something unexpected happens in March, you'll be among the first to know. The universe just proved it's full of surprises, and we're just getting started. Thanks for watching. See you in the next one.